Hi friends, in this video we are going to see about linked list concept which is available in the unit 1. So first we will see linked list operations and implementations. So here linked list entity is nothing but a set of elements that are stored in particular order. So here we have 6 operations. One is printing the list and empty the list, and we can find the elements in the list, and we can insert the element and particular position and delete the element, and also we can find the element in which particular position what it is available. So these are the 6 operations can be done in list ADT, and list ADT can be implemented using three ways: array, linked list, and cursor implementations. So all the three concepts we will try to see in this video itself. So this is an example. A list of elements are available in the particular screen. So 32, 12, 52, 16, 12. So if I try to find 12, the first occurrence of the 12 will be displayed as an answer. The find operation, it is in syntax that find keyword and open bracket. Within that you are supposed to mention the values and close bracket. Once it is done, the answer will be given to the user. So 52 is available in the third position, so this is what the answer. And find kth is nothing but we can mention the position. From that position, what are the valuable available in it, that will be displayed as an answer. And for insert, you have an syntax like element to be passed as in first argument and position to be passed as in second position. So insert element and position. So in the list, in the fourth position 20 will be inserted. Then for delete, the value which you are supposed to give, that value will be deleted. After deletion, the answer will be available in the screen. So this is an example for list, and that 4 operations are performed here. So you people already know what is array implementation. Array is nothing but a static data structure, and it have fixed number of elements can be stored in it, and we have only similar data types can be stored. And if you want to delete or insert the element by using array implementation, it will take more time to insert and delete the element, and also it is cost effective. So it is highly difficult to implement the elements in the array insertion and deletion, because it have to move from one position to another position. Next position it have to move for insertion or also deletion. So in order to avoid this, we can so because of this we have waste of space and also difficult to change. So these are and it will take more time, and it is very slow process to do the things. So in order to overcome the disadvantages in list, array, we can go with the linked list concept. Here it is also a linear cast, but we can give link to the another element, so it is easy for us to identify what will be the next element by mentioning the address of it. So here it is an example: a1, a2, a3 and a4. Last is you have a null. So address of a4 will be stored in a3, and a3 address will be stored in a2, and a2 address will be stored in a1. So likewise, so it will mentions that if the node consists of two things. One is data element, and then next pointer. So in data element, value will be stored, and in pointer the address of the next element will be stored. So likewise you can have a representation of data and its memory in it. So this is an example of singly linked list. So here in singly linked list, you have two nodes. One is data, another one inside a node we have two sections. One is data, another one is next pointer. So as like an example, the first node will be in a header, so data will be available, and the next data's address will be stored in the next pointer. Simultaneously it will be done for remaining nodes, and for last node the next pointer node will be filled with null. For doubly linked list, you have three divisions in the node. So one is data, remaining two is prior or previous pointer or next point and the next pointer. So this is an example for doubly linked list. This is an example for doubly linked list. Inside data, we can store the data in next pointer as like your previous. The previous next data's address will be stored in the next, and previous will be stored with previous data's address. In the same, it is an example. So A's address is 11 and B's address is 15 and C's address is 17 and D's address is 19. So A's next pointer holds the B's address and B's next pointer holds the C's address, that is 17, and C's next pointer will holds the D's address, that is 19. So this is the filling of next pointer. And now I will show the previous pointer. A's previous pointer, you don't have anything to start before that, so we can mention with start or null with it. So next, B's previous pointer is 11 and C's previous pointer is 15 and D's previous pointer is 17. So this is how doubly linked list will stores the data and previous and next pointer. And for D, we have at next pointer we have null. So this is a circular linked list. The last element and the first node, last node and first node will be given with the connection. So this is how the circular linked list. And for doubly linked list also in the same way it will be rounded with previous next pointer to the previous of the first. And using linked list we can do operations of 4. One is insertion, deletion and searching and display. For searching and display, we can search the element whatever we want, and we can display the we can display the element which is available in the list. So for insertion and deletion, we can do both the things in 2 positions, so 3 positions. One is at the front, another one is last, and another one is in middle one. So in these 3 positions, we can do insertion and deletion. So this is how a declaration statement will be there. So that, see at the last, the struct node, the node consists of element and the next pointer, it's a position. And above it, you have a list of headers. So it will have some list of functions: empty, is empty, last, find, delete, previous, insert, delete, header, find and advanced and retrieve. So these are the header files, and for that we are supposed to write in code for linked list concepts. So thus the routine we will see in the next video, separate video. Now we will go with cursor implementation. So if some languages won't support pointers, so we can go with the cursor concept. So this is a concept of global array of structures. So first image, it shows that what will be the next element. So first slot, first row will first column will be slot, and second column will be element, and third column will be the next. And for the next image, it shows that in first image it won't stores the data. In next image, second image, it stores the data. So for example, now starts with header, it's slot 3. So 3 header and next is 7. So 7 holds C. After C we can have 8. So 8 holds D. After D we have 2. So 2 holds F. After F is 0. So this is the structure of data stored using cursor. So next example is header. First, it is in 5th slot. After header we can have 10th position. It holds A. After A it holds 1. It holds B. So after B it holds 9. So 9 holds E. E holds 0. So this is how cursor implementation is done with this global array of structures. So routine we will see in the next video. Thank you.